Hello everyone, my name is Kent and this video concerns the photography of printed circuit boards and creating high-resolution composite images suitable for reverse engineering. We'll look at the hardware, the software, and most importantly the process involved in creating the composites. We'll start in the shop to take the photographs and then come back here to process them. I have to warn you, the video from the shop is done with a handheld cell phone camera and my hands are pretty shaky. Sorry about that. Let's get started. The stand is home built from plywood for good support on the table, and then additional backing in order to keep the main part of the stand flat. Using a home-built stand over a tripod, I can get a lot more reproducibility, and I can also square it up to the subject easier. I can put a square on the side and bring that across to the lens, and just be sure that the lens is square to the board. This board is actually washers underneath of it to support it so that it's flat. Being square is important, as otherwise you have perspective distortions. If the board is tilted in any way, then the area that's tilted toward the camera is going to appear larger. As uniform as you can get the images, the better the stitching will work. Everything that's automatic on a camera has been disabled. The lens stabilizer has been turned off in a vertical orientation. Just doesn't work very well. Auto rotation of the images has been disabled, and a vertical orientation. It doesn't know which side of the camera is toward the ground. It'll keep flipping around between different image orientations. The camera is attached with an HDMI cable to a monitor to the side, and this is just to make it easier to see the fine details and make certain that the focus is good. Some styrofoam front and back just to bounce the light a little bit. The board is on this black mat. It's important to have something which is uniform and that you can move the board on. The worst is having the board on a wooden surface with a lot of grain, a lot of texture, and then moving the board on that surface. If that's done, then all of that background has to be removed from the image before stitching will work well. So a black uniform background is going to make life a lot easier when stitching. And I can take this and just slide the board over to the side, not touch the camera or the stands or the lights at all. And that means that the board is moving through the same light field. Settings for the camera, again, everything manual, so it's manual mode, manual focus, manual exposure, manual aperture, and manual ISO. But the ISO is as low as reasonable while still keeping the exposure reasonable as well. If I go much above 400, I start to see a grain in the images. If I go to the smallest aperture, that is the largest value, the images start to get a little bit fuzzy. 22 seems to be a nice compromise between getting the largest depth of field and keeping the images sharp. Try to get good focus on the traces and then rely on the depth of field created by, given to us by the aperture setting to get the tops of components. If a component is especially high, like some capacitors, the relays are really tall, I'll cut out a section from a separate image that was at a higher focal plane, and then I'll paste that into the composite image. It's for documentation, so we do what's necessary in order to get all the information that we can from the board in case we never see this board again. It can easily overexpose a board, and details in the labels and the traces start to be lost. So even though the camera has more noise in the darks, so it's better to overexpose images in general, realize that since there's so much black in this image, that the histogram is going to be toward the left. I like the lights at kind of a low angle to the side. It really helps the component IDs show up well. If the lights are high and to the side, it becomes difficult to read the labels. And if the overhead lights are on, then there's a lot of specular reflections that occur. So these solder joints are really shiny, and you end up with these specular reflections that any detail in that joint is is lost. If you're only interested in the traces, it doesn't matter too much, but if you want to inspect the solder joints, in particular for cold solder joints, it's nice to have more detail in the solder joints. Multiple exposures would be another way. The camera has a 10-second delay after I press the shutter. The delay is going to allow time for that vibration to settle out and the camera is stable. And remember, the lens stabilizer can't be used in this orientation. All right, so let's review that image and see how it looks. Now we're reviewing this for exposure. So I think this is a little bit bright. So I'm going to reduce the exposure just a little bit. We'll take another image. All right. And take a look at that. Okay, that looks beautiful. So let's use that exposure. So since we're going to use that exposure, we can turn off the histogram. And now you see these grids. So it's something that the camera puts into this live view. All right, so this line, this grid line, is pretty well aligned to the side of the board, and we have these holes for reference. If you have a remote release, or if you use computer control of the camera, then you don't need to use this delay function. I'm just sliding the board over a little bit at a time. These stitching algorithms, they're set up more for creative photography, and they'll automatically stretch and warp and tinker with the images to get them to fit, to meet some measure of quality. And with details like board traces and dimensions, sometimes it gets distorted. All right, so I think that's all we really need of this board. I'll flip it over, take images of the other side, and then take some summary images. All right, let's get started. The first thing to do is go to Photo Merge. Start with the back of the board, and I'd like to compare the difference between using the raw images to using the JPEG images. Because if we can use the JPEG images with minimal loss of clarity, we're working with much smaller images. And here it is merged. And let's go ahead and repeat this using the JPEG images. I don't know how well this is going to work, but let's zoom in to the same percentage in both images and see how well they align. That's not too bad. All right, so the raw image, you clearly see more texture in the image. The JPEG image is a lot softer. Now, that texture is likely a bit of grain, but does it add to the clarity of the image? Does it make the image more useful? I don't think so. If anything, the labels on the components pop a little bit better with the JPEG image than they do with the raw image. So I think we can use the JPEG images. All right, so let's close the raw version, and we won't do anything more with it. After merging, it's interesting to see what has been used from each image. You click on this eyeball in the lower right to turn each image off, each image from the camera off. They're each brought in as a separate layer. And if there's going to be any mistakes, they're going to be at the point where two images are joined together. And you can see maybe a little bit of maybe this line, this shifts just a little bit between these two images, but it's extremely usable. And it's really amazing where Photoshop chooses to make a split between the images. Here's another spot that could potentially have some problems because of the depth created by the crystals. So you might see a difference in the shadows. It'll rarely cut across something that has a great deal of depth, but it can get confused if you're seeing the component from different angles and different images, and it tries to mix those together. But this looks really good. All right, let's repeat the same thing on the back side of the board. So automate photo merge. I just leave everything set to default auto and blend images together. All right, the front side, I'm going to use the JPEG images. All right, so again, let's just toggle through these images. And that one doesn't contribute very much. Neither does that one. Looks like we get by with 3 images, no problem. So how about we just zoom into this area here, and you see anything that looks, I mean, this merging looks great. This is fairly linear, right, where we move the camera or move the board in only one direction. In cases where you have tiling in 2 dimensions, it's easier to find problems. To keep the board flat helps avoid those problems. Save this. You could actually use this as the archive and get rid of the JPEG images. So it has all of the JPEGs in here, so might not be really any need to keep them. Let's put a black background on them. All right, so that one, save this again. Flatten the image, and just going to grab a copy of it, come over to the other side, all right, put our black layer here as well, save it. Let's flatten this image. All right, now we can paste in. And let's rename these so they make sense. And I'm calling front the side that faces the push buttons, and back the side with all the components. All right, now we can adjust the opacity to see through each side and tell they're not quite aligned. And in one way they're not aligned. If you look at the battery connection, you can tell it's flipped, right? So let's go to transform and we'll flip this vertically. So now at least the battery connections on the same side. And on this top layer, we'll make it slightly transparent and then move it over. Right? We can zoom in, do this a little bit nicer. All right, so now they're aligned on the left side, but we see that there's some problems with them matching up as far as their length and a little bit as far as their their height. Before stretching this, what we need to do is align them in one more way. They look close, but they're not quite straight. So let's measure this, and that's actually 0. That is perfectly aligned. And this board is -5. Alright, so we're going to rotate the top. And we want to rotate it negative, let's see, 0.5. Is that right? No, -0.5. Alright, so that's looking good. Let's double check that we're aligned on one side, and we are. Holes look good. Now let's start warping the image. Okay, free transform. Let's hold the left side rigid and slide this over. Looks like the bottom side is pretty good now. Move it a little bit, stretch it a little bit this way. Again, we have to handle the far right side a little different. And just want to zoom in and see how we're doing with respect to some of the vias. Alright, so as the top layer fades away, I'm having a hard time really telling where the top layer vias are on the bottom layer, where the vias are on the top and bottom. So I think this is aligned pretty well. Alright, I think that looks really good. Let's lock this one in, do its transformation, and let's save this. Now, the right side we have to handle a little differently, and the problem is everything is aligned up to about here. Let's see, where does it start getting messed up? About here, somewhere around here, things start going wrong. That happens to be right where this white box is at, and this is, I think, fluorescent material for the LCD panel. The amount of detail in this is not as great as in this region here. There are traces, but they're faint, and what I'm guessing is the stitching program just doesn't see those details. Like, of course it sees the holes, but it has nothing to guide it. So it's looking for details such as traces, and these are just too faint. So what we'll try to do is grab just this side, and let's check where the vias start getting messed up, and move our selection to be close to there. Yes, back it off just a little bit. Alright, and then we're going to do a free transform again. We're going to lock the left side down because we're happy with the vertical arrangement, and the left side is well aligned. I'm just going to stretch the selection. There, that's looking a lot better. Let's go the other side. Okay, that looks better, all except for just a few up in the corner. So we can't warp this just a little bit. All right, so I think that's probably going to do it. Again, you know, these photo merging routines are they're not perfect. It'd be nice to be able to give some hints to Photoshop about where things should be aligned, you know, point out the vias. All right, I think that's going to do it for this one. Yeah, maybe there's still a few that are off, but it's definitely very usable. And you know, this is really interesting, right? Because what you can see is there's a lot of vias underneath the processor, vias under the ADD converter, analog multiplexer. There's a lot of vias that are hidden if you're looking at only one side of the board. It's really interesting. It's really pretty powerful, and of course this is only going to be helpful for. Well, it's going to be helpful for any board, but I know it's going to be most useful for 1- and 2-sided boards. All right, so let's now come in here, deselect everything, and I want to just crop this down so it's a little bit. Oops. Let's crop this, clean it up a little bit. Okay, that looks pretty nice. Save this. All right, the next thing we do is we can duplicate the front, duplicate this layer, duplicate layer. And this doesn't always work well, but we'll give it a try, and that's to do a color range selection. I'm using this localized color clusters because that seems to work pretty well when the colors are changing across the board. It does mean that you have to select points, different places across the board. You can't just select one. But all right, so this actually looks pretty nice, right? Because the traces really show up with that background removed. Let's look at the front layer. It's okay, right? There's still a lot of junk contained in here. And if we go back and do color range selection again, we may be able to remove some of that. Yeah, all right, that looks pretty nice. So here's the original back. I guess I didn't make a copy of the back here, but here's the original front. Here's the front with everything but the traces removed. And what works nice sometimes is put a white background to really help you see the traces. The color selection for isolating the traces isn't perfect. I think there's a real chance to create some software that would identify the traces, knowing that they're going to connect VSs, they're going to connect pads. Let's try that. Shall we? Let's bring the front layer back and do a color range based on the gold color and see if that works better. And let's turn off localize color. Right. We'll just crank up the fuzziness until it looks like it's going to work. Yeah, obviously selecting the vias is pretty easy to do. Now we got a little bit extra stuff, right? We got the labels, but we also increase the color range pretty substantially. Let's go in, let's try something here, and we'll subtract off, which ones? We'll subtract off the white. Let's see what we can do there. And now it looks like we're doing pretty well. All right, so the vias were pretty easy to identify just by their color. I don't know, maybe that's a future project to make a program to find the vias and then use that information to find traces, and you know, work with two-sided boards, one and two-sided boards. Don't try to get too fancy with it. I don't know, might be kind of interesting to do. All right, so I think we're done with this board. All right.